Now let's take a look at example 3. It tells us to write an expression in expanded form that is equivalent to the model below. Now so far in all these other examples, we've been modeling with a tape diagram or a bar model. This time, another way of thinking of it is to use an area model. And so you have to understand that we're finding the area of a rectangle. And from previous years or from geometry, we've learned that area equals length times width in order to find the area of a rectangle. So we could assume that we have one large rectangle here, and the dimension of this length is going to be y, and the dimension of this entire width is going to be the 4x plus 5. So what we can say is if we substitute the length as y and multiply it by the width, 4x plus 5, we get a factored form of y times the quantity 4x plus 5. We're taking y as our width times 4x plus 5 as our, y as our length times 4x plus 5 as our width. Now, how can we rewrite this expression in expanded form? Now we can understand this in our model by noticing that the rectangle is broken up into two smaller rectangles. I'm going to put them in two different colors here so that we can see the difference. So once again, remember, we can find the area of the entire big rectangle by going y times the quantity 4x plus 5. But we can also break it apart in just two smaller areas by going the area of the red rectangle as y times 4x, because y is the length of that rectangle, and 4x is the width of that one. So we can say y times 4x. And then we can find the area of this blue rectangle. Notice that it's the opposite side here, so the length of that rectangle is y, and the width of this is 5. So length times width would be y times 5. And then we could put them together. So I'm going to clean it up a little bit here. We can put y times 4x as 4xy plus the y times 5 as 5y. This area of the big rectangle equals this area. The bottom one illustrates how we're adding the areas of the two smaller rectangles together to get the area of the big rectangle.